basically an already created game made as part of a Final Games?
No, it was part of 526 class,
Okay.
mobile games class. So we made it last semester. So it was made for an iPad. I was part of the original team. Chris was actually our lead for that game. So this is a RTS, real-time strategy game, created in tower defense style, based on resource accumulation and then survival goals. So it basically showcases a battle between humans and zombies, where zombies have taken over the world, and you're just left with 3 humans at the beginning, and your goals are to explore more and more area of the game to find more humans and resources. Also, the resources go on decreasing, so you have to make sure that you explore, otherwise you are not able to survive. So the game is designed in such a way that it's encouraged that your players explore more, rather than just like defending one particular area of the game.
Right.
So that,
Oh,
yeah, just go ahead.
So our big basically goal for this class is to take this game, which initially only existed as an offline thing, offline title, and make it so it can work online with networking, because it's network games. And I think we'll just kind of show you what we have so far, and then we'll start talking about the tech behind it, the approaches we use, because we actually tried several different approaches to networking. But just to show you what we have, so we'll start a server here, and then on right here I'm going to start a client copy, and anything that's done on the server gets broadcast to clients. So we have zombies that get spawned and mingle and sometimes move. And on the client, their positions are constantly being synchronized, as well as their rotations and their health. We have on the server a set of humans, which can be ordered around, and also their positions are constantly relayed to all clients. The rotations are relayed as well, although they are a bit less, updated a bit less frequently to save on bandwidth, because it's not as critical to the gameplay. And
So how do you distribute, or what is the method of broadcasting?
so right now we're just kind of using for broadcasting direct IP. Actually, both the client and the server copies right now have hard-coded in the IP addresses that they're to connect to. But one of the next steps we want to do is to make it so a user can input an IP address to connect to.
Are they talking peer-to-peer?
Yes, it's completely. It's a client-server model. Yeah, it's a client-server model, but we're not using any central servers provided by Unity. We're just having someone sets up a server, ports are open, and other users can
First
connect.
person to create a game becomes the server, and then all others join become the player.
Right. And the last thing that we have currently implemented is that in the server, users can enter buildings and garrison, and then you find more survivors. And then on the client side, which is down here, that this is reflected as well. And then they can also exit the building. And you'll notice there's a fourth person here. That's because basically the humans have found another survivor. And then in the original game, whenever they enter a building, they have a chance of finding an extra human who will then follow around with them in a different control. That is synchronized as well.
There's always a chance of finding a certain number of humans or zombies which are already garrisoned inside a building. So you always have a chance of finding a certain amount of resources for each of them, as well as a 50-50 chance of finding a zombie or human. So there's a fight that happens internally, and suppose if there are 2 zombies and 3 humans are going in, then just one of the humans will appear back.
That's right.
And the resources, as you can see, the food, ammo, hardware, food goes on decreasing proportionally to the number of human players that are there on the game. So if you find more players, that means you have to explore more in order to support your population. And hardware is just for building barricades to create defensive structures so that you can protect your main building. This is the night-day cycle that you have synchronized across clients,
Yes.
so that during the night cycle, the zombies spawn more frequently and are more powerful than during the daytime. and they actually have a better recognition of the main building, so that they all move towards the main building and start attacking. Whereas during the daytime, they just wander aimlessly.
So another thing that is actually synchronized is zombies deaths and is zombie death. So as the zombie dies here on the server on the client side, they also begin to die here.
So basically, as of now, we have a one-way network game where a human player can play, but on the zombie side, we have not implemented any controls for now. So for this half of the semester, we just planned on implementing all the human controls, making sure that we got the score system, the resource system right, and the spawn points, making sure that they were consistent. But during the rest half of the semester, we are planning to work on implementing the zombie controls, so that when the client does something on the zombie side, it actually makes zombies spawn or something.
Yes. So moving into the actual implementation of how we did everything, because the real meat of this is in the code, since most of what you're visually seeing was already in the game as we got it. Initially, we decided to look into just creating our own packets and converting them to character arrays and sending them over UDP. But we found that because of because of the unreliability, we weren't properly prepared to handle cases if we lost critical packets. And since our game doesn't have that many actors at one time, there's only like say 12 or so zombies plus like 5 or so humans. We found that while we don't want to go as strict as TCP, Unity's built-in networking systems are have a bit more reliability, which for us proved to be a nice compromise. So we looked at Unity's networking policies, a networking system which has both network views and remote procedure calls. And at first we looked into network views. Do you want to explain how that worked? Or? Well, basically, with network views, we found that we had issues kind of sending the exact information we wanted to. We couldn't, while it was easy enough for us to synchronize transforms and locations of certain things, it was difficult for us to actually invoke a function of a specific instance on both sides of the server.
Network view is essentially just broadcast state.
Exactly.
State changes.
Yes. Each network view picks one type of thing to broadcast, and the default option is transform, but there's a few other options. But because it's just broadcasting state changes and nothing else, we found it a bit hard to know exactly what the ID of each thing is, since that's allocated at created at runtime. So instead, what we did is we have a singleton network manager, and this is the only thing with the network view. So the network manager is state is shared across the network, but everything else isn't. And whenever something significant happens, such as something moving, something being created, a zombie dying, a player entering the building, a call is made to the singleton class, and then that singleton class then creates a remote procedure call to its double on the other side of the network. And with this, we were able to get a lot of flexibility in how we wanted to do different things. The other thing we had to do is give every entity its own unique ID based off of what it is. So each zombie has its own unique ID, which is simply just an integer that increments whenever a new zombie is created, similar with humans. And all existing zombies and existing humans are stored in array lists that the network view has access to, and that via code we make sure are synchronized. So if a zombie number 3 on the server dies, it sends a message to the network singleton saying, hey, make sure that zombie number 3 is dead on all clients as well. And that broadcasts a message saying, destroy zombie 3. The other network singletons on the clients get that message, and then they execute the proper code to make sure that happens as well and remove them from their list. And so that's the general paradigm algorithm what we're going with, and it seems to be working out pretty well. Yeah.
Super. All right.
Is there anything else?
So I think from now on they're just going to concentrate on adding some more game features, and then the major network part left is actually synchronizing zombie controls across multiple clients to the server.
Mm-hmm.
So that is the main thing that is left on the networking side.
And then if we have any time, this is a kind of a bonus thing, but if we do have time after finishing all the the zombie controls, we would like to implement, just to kind of make sure that we still understand the whole manually creating UDP packets, we'd like to implement a chat system with manual UDP packets. This is kind of a side extra bonus thing if we still have time for it, but it would be nice to be able to say, hey, we've tried all these different things and they're all in here, and so we're able to convert things to character arrays, byte arrays, and then revert them and be able to unpackage that message and get the message intact. So that's something that we're looking into, but that's lower priority.
Right.
Okay.
This is your whole team?
Yes. Joseph Goldberg,
Ajinkya,
Kathleen, and yeah, thank you.
All right, thanks.